So this is your prompt, and this is the first token of the prompt. This is the second token of the prompt, and so on. And this is the last token of the prompt. So let's say you're implementing a chat application, or any conversational agent will involve a system prompt. So this is the system prompt. During the interactions with the user is going to ask a message. So this is the first user message. Then the agent is going to reply. So this is the agent response. Then the user is going to send the next message and the agent will respond. Every time you ask a question, the system prompt is going to be loaded into the context. So this is the full context of the agent. And also your message is going to be added to the context. And then this context is going to be sent to the LLM to then answer your question. Now, the second time you ask a question, so your second query, what happens is that the system prompt is going to be loaded again in the context. So this is the new context that is going to be constructed for the second request. So the system prompt is going to be loaded again. The first user message is also going to be sent to the context. The agent response this time also is going to be sent. And also your second message is going to be sent to the context. I know this has got messy here, but the point is we build a new context from scratch, and then this new context is going to be sent again to the LLM to then generate the second response. So here, if you have noticed, we got two contexts. We got the first context for the first request and the second context for the second request. The system prompt didn't change between the first question and the second question. But here we loaded twice in the context. We loaded here once and we loaded here twice. This is going to increase the token usage. So the cost for the generation is going to be higher, and also the latency is going to be higher. The agent is going to be slower. So now to avoid that, prompt caching is implemented. So let's say this is the original prompt. Now we're going to send a new request. And with that request, we sent the same first token, the same second token until the last token. So the first basically chunk of the system prompt didn't change. Only what changed are the last two tokens or chunks from the prompt. We do not pass the whole thing again to the LLM. We only pass the first part to the LLM, and therefore we save around like here more than 90% of the cost. So it's a huge save. Now, on the other hand, if the first token or the first chunk of the prompt is different, as we see here, it's different from the first one. Now we have a cache miss, and therefore the entire prompt needs to be passed again from scratch to the LLM. So let's see how is that implemented in practice. So here I have demo with Claude Sonnet 4.5. So first, let's take a look at the pricing of Sonnet 4.5. So the input cost is $3 per million token. The cache write is 3.75, is the cost of writing the part of the prompt that we want to cache. In this case, we need to write this part, the green part here to the cache, and this is basically a one-time cost for this chunk. And the cache read, so to read from the cache, is not completely for free, but here they charge 10% of the original pricing. So we save basically 90% of the cost. And the output cost is 15 per million tokens. So here we have two tests. First, without caching. So first I have a base document. So let's say your data is in one document, and then you need to pass this document to the system prompt. So here's the system prompt now. You are a support agent for the SaaS platform, and this is the documentation that we want to give to the LLM or to the agent. And here we have a set of questions that we are going to be asking the agent during the inference. So the first test is without caching. So what we do without caching, we iterate over the questions, and then we pass the system prompt, and then we pass the question and we generate the response. So every time we send the system prompt and we send the question and we get the response, and then we calculate the time and we also calculate the cost. So now the second test with caching. So with caching, basically we do the same exact thing for every question. In the question set, we pass the question, and also we pass the cache control parameter, which is the parameter that we use to cache repetitive parts of the prompt. And this cache type is ephemeral, means that temporarily caches the tokens. It saves it like for 5 minutes, and then after 5 minutes it's gonna be lost basically. There is an option, you can add the time for how much you want it to be saved, and you can have it for 1 hour, but the cost for caching is going to increase. But for 5 minutes, for example, for a conversation, if the user is having a conversation right now with the agent, so within a 5-minute window, that can have significant cost reduction and also latency reduction for generating the response. So we do the same after that. So we generate the response using this cache control parameter, and then we calculate the time elapsed, and also we calculate the cost. So let's see the difference. So first, without caching, the total size of the prompt with the question. So here's was the question: what is the refund policy for the annual plans? So the size of the input of the prompt, the system prompt, and the user query was 2,607 tokens, no cache writes and no cache reads, and the output was 110 tokens, latency 4 seconds, and the cost was this. Same for the second question, same for the third question. So the total cost without caching was 0.02. dollars. And now let's see the same. Let's compare the results with caching. So with caching now, at the beginning, we do a warm up to the cache. So we send the request just to do the write to the cache. So when we ask a question, we have a cache read from the first time, like basically we have a cache hit. So here we ask the first question. As we can see, the size of the input now is 15 tokens. It's not 2,607 tokens, but instead it's 15 tokens. And the cache read is 2,592. And if we add the two, so 15 plus 2,592, it's 2,607, which is exactly the same as the input with the original prompt. How do I contact support for the business plan? So the same thing here, 15 per input, cache read, 2,500 tokens. So the total cost without caching is 0.007. So with caching, the cost was 0.02. The cost with caching is 0.007. And the total saving is about 75%. So this is just 75% cost reduction, just simply from one parameter here, which is by applying basically the prompt caching. You can easily overlook this. And when you're working with a system where or with an agent where the system prompt is mostly fixed and only the parts that change are the parts at the end of it, you can then consider the prompt caching. It's going to give you significant cost reduction. It's 90% actually the cost per input, because the cache read cost is 10%. As we see here, is 10% the input cost. And here in total we saved about 75%. For your case, if you have a larger document and you have more frequent requests, then the savings for you is going to be even higher. So yeah, so this is, I thought, an interesting topic to cover in this video. So yeah, that was all I wanted to share with you. I hope you enjoyed it. Thanks so much for watching. See you in the next one. Bye bye.